Hyster in here with a Mazda engine, alright, that seems to be running fine when it's idling right now, but I don't know if you heard that. The ticking noise for sure is coming from the valves themselves, but if you raise the RPM slightly, I don't know if you heard that, that's knocking noise now, alright? So we're gonna try to figure out, now it's never going away, but it seems to be louder as soon as you raise the RPM. So we're gonna try to figure out where that knocking noise is coming from. What I'm gonna try to use to pinpoint the noise is this clip that I made and I glued on a PSO, and then it's gonna be hooked up to channel 1. Look at the screen, okay, set it steady, and once this encounters, see how it's reacting, there you go. Alright, so this is going to react to vibrations, and hopefully what I'm trying to achieve is we can pinpoint where exactly that noise is coming from. So I used a stethoscope on this engine earlier, and it seems like it's coming from the number 4. It's loudest at number 4, but in order to be graphical about it, we're going to use this same way as we're using the stethoscope, and then we're going to transfer it from cylinder to cylinder. We're going to attach it somewhere, clip it on somewhere into the block which is closer to the cylinder 4, and then cylinder number 1, and so on and so forth, and try to see if the amplitude is any stronger at cylinder number 4, which I doubt has a knocking noise.
Okay, so this is the waveform that I have been able to take. Sorry, but I was not able to take an actual video of me using the homemade knock sensor that I did, but the green trace is going to be for cylinder or closest to the cylinder number 1, and the blue trace is closest to cylinder number 4. So as you can see from my research on this, the noise or the waveform will be more frequent or larger frequency when it's closest to the source, and I think that is the case here. So as you can see on the green trace, the waveform is not as frequent as it is on the number 4. So the frequency is higher on the number 4 as comparison to the frequency on the number 1. And also the amplitude of the waveform is much higher on the number 4 than it is on the number 1, or closest to the number 1 cylinder. So I think we're going to check the number 4 on what's happening with this, and go from there.
So spark plugs are out, valve covers out. So what we're gonna do is we're gonna try to rotate this engine manually with the crankshaft, and then you know what? First cylinder would be, I guess. Let's look at the number 3. So what we're gonna crank it, and then we're gonna watch for that intake to slowly go up. Okay, exhaust intake is coming up. Okay, so that cylinder now should be on its downward stroke. Okay, so we're checking cylinder number 3. This is the intake. So because the cam is already rolling on it, started to, okay, meaning to say that the piston is already starting on its downward stroke, and I'm gonna put in an extension here. All right, and then I'm gonna feel for that piston, the top of it, and then slowly try to push on it, see if I get any movement. Okay, pushing on it, and it's solid. Okay, so we have no problem with this one. So now let's go back to the number 4. Same procedure. We're gonna crank the engine manually. We're gonna wait for the intake cam to go up slightly, all right, so that we know that the piston is already starting on its downward stroke, and then we're gonna do the same test. So cylinder number 4, we're gonna watch for that intake rocker on number 4 to slowly go up. Should be coming up now. Okay, there it is. So mean to say our intake valve is starting to open, so more likely than not our piston is already in its way down. So we're gonna do the same test. I'm gonna put this extension at the spark plug hole right here. That piston, okay, you hear it, it's hitting that piston now. So I'm gonna try to push down on this extension and see if we get any movement. Okay, yeah, okay, there is movement there. I don't know if the camera caught it, but there is probably like 1/16 of movement. Now it's solid, but there is movement there. So that proves the point that, okay, we have a rod knock. Okay, so now this is gonna be, the engine has to come out. So the customer wanted an assessment for this first. I don't know if the customer would want to fix this, right? But I'm gonna end the video with this right now. There's nothing else that we can do on this unless the customer approves the job to tear down the engine.
So the customer decided not to go ahead with the teardown. He's not going to be fixing his truck anymore. Um, so it does not give us an opportunity to tear it down and exactly see what is making that knocking noise, be it on the top end of that piston or it's in the bottom end. So what I did was I took a pressure transducer into cylinder number 4 because we already know that it's cylinder number 4, and then also took the homemade knock sensor along with it and ran it. So this is the compression waveform of in-cylinder waveform of the number 4 cylinder. So as you can see here, this piston or this cylinder was able to make 82.98 psi during idle, which is not bad at all. But here is where the knocking noise is occurring, right here. That's the knock, and it's happening right after the 360-degree mark, right here, after the overlap, uh, when the piston is already starting on its downward stroke on the intake. So that's our 360. So it's actually happening 15 degrees or so after the piston has hit the 360 or top dead center before the intake stroke. So this would make me think, again, doing the research on this, this would make me believe that our knocking noise is coming from the piston pin. And the explanation on that, when doing my research, is that when you're going up, if it was a rod knock, if it was the bearings on the journals or a bearing on the bottom cap, or let's say, uh, the sound would be more pronounced when it's going up. But if it was on the top end of the rod, which is going to be the piston pin or somewhere along that line, it would be more pronounced when the piston is going down. So with that, I think that this cylinder has a problem with the piston pin because the knock is happening when the piston is on its way down. Okay, so unfortunately we're not going to be able to see this or prove this, but I think that this is like a good practice on using this knock sensor for determining where the sound is coming from. So with this, I'm going to end this video. Hopefully you learned something from this, because I did a lot.